Alright, so this is Algebra 1, Unit 2, Lesson 3. Okay, so in Lesson 1 for this unit, we went over how to solve an equation that's a one-step or a two-step equation, and including the literal equations, okay? Then, in Lesson 2, we went through how to solve a multi-step equation, where we had variables on the same side or we had variables on both sides, okay? Alright, so here in Lesson 3, we're just going to look specifically at those special equations, the weird ones, the ones that don't give you one of those answers that you're used to getting. So these are examples of what we've worked through in the last two classes. So just to show the work on number 1, as I go through 4x minus 3 equals 17, add 3 to both sides to cancel, and then divide by 4, you notice I get x equals 5. This is what happens most of the time when we do these linear equations, when the exponent's just a 1. We get x equals a number, okay? Now that number could be positive, negative, a decimal, an integer, it doesn't make a difference, you get x equals something. Most of the time that's what you're going to see. However, you also can see when the x's are canceled on not just the left, not just the right, but both. So there's 2 times when that happens. Let's look at those 2 special equations. Alright, so our special equation. So here I see 5, parentheses, x minus 4 equals 5x plus 12. So I would distribute the 5 in. 5 times x is 5x. 5 times negative 4 is negative 20. And then I'm just bringing the 5x plus 12 down. Well, now I would try to get the variables on the same side because they're on opposite sides. So I'm going to subtract 5x. But when I subtract 5x on the left, 5x minus 5x, 5x minus 5x, it cancels not on the left, not on the right, but both. So now I would bring the negative 20 down, I'd bring the 12 down. So since there's no x anymore, notice what we're left with. Negative 20 equals 12. So if the variable cancels, then you need to say to yourself, is this a true statement? So no, negative 20 does not equal 12. So since this is not true, then what we're going to say is that this problem has no solution, which means no matter what value you try to plug in here for x in the problem, you could never get the left side to equal the right side. So anytime the x's are eliminated and you end up with a false statement, it is no solution. So now let's look at the other type of special equation. So here I see that I've got my equation. I'm going to combine like terms on the left side. 7x minus 3x gives me 4x. So I get 4x plus 14 equals 4x plus 14. I want to get the variable on the same side because they're on opposite sides, so I minus 4x from both sides. When I do that, again, it doesn't just cancel on the left or on the right, it cancels on both. So now I'm left with 14 equals 14. So now, notice here, where did the x go? Well, the x is eliminated on the right and the left, but the difference here is, unlike the last problem, this statement is true. 14 does equal 14. So then what we would say is it is many solutions. We have many, technically we call it infinitely many solutions. So to recap, when the x's are eliminated, or the variable of any kind are eliminated on both the left and the right side of the equal sign, then it leads you to one of 2 special equations. If you end up with a statement at the end where you have one number equals a different number, that is false, so then the answer is no solution. If on the other hand, the variables are eliminated and you get a number equals that same number, which is a true statement, then you would say that is many solutions. Hope this helps for Algebra 1, Unit 2, Lesson 3.